All right, so let's look at this homework, Bridges Math 4th grade, Frankie's fractions and decimals. And by this point of the unit on fractions and decimals, we should be pretty good with most of these. And this first one's very familiar. We're talking about 12 eggs, and he used 8 of them. So we've done this before. But with this egg carton, we have 8 of them being used. What are the fractions? Well, I would go for at least, well, it says you'd have to do 2, but you could do 12ths easily. You could do 6ths. You could also do thirds. So go for 3 if you can with that one. And then this next one, we're talking about quarters. So this one you might need some help on unless you're familiar with American money. But basically, you need to know a quarter is 25 cents, right? And a dollar is 100 cents. So right away, you have a fraction there. Out of 100 cents, how much is a quarter? The other way to look at it is to think about, okay, if you had 1 quarter, how many quarters would you need for a whole dollar? So, right, if you had 2 quarters, that would give you 50 cents. How many quarters would you need to get a full dollar? And that number of quarters would go on your bottom, 1 out of that many quarters to make a dollar. And then write the decimal number of this one over there. How do you write that as a decimal? In this next one, I think you got that okay. Granola bars, 3/8, 4/8, we should be okay. For these, again, I think converting tenths to hundredths is pretty simple. You can think of a hundredths chart if you want, but basically 2 tenths is the same as 20 hundredths, and you just follow that pattern. Now down here, I think a lot of these you'll be okay, but please be aware of 3 of these where you have both tenths and hundredths, because some people have missed this a little bit. So for these 3 right here, you're adding tenths to hundredths or subtracting tenths from hundredths. So it's probably helpful to rewrite these. 51 hundredths. That can stay as it is, but 2 tenths will need to move into hundredths. So that becomes 20 hundredths, just like we talked about up there. And then you can subtract that and figure out the answer. And that answer you could probably put back into tenths, or you can have 2 answers. But I'll let you sort that out on your own. And same deal here. Just be aware you need to change these. And finally, let me make a note about this one. If you have 2 fourths and 2 fourths, you can add those together. You can add 3 and 1 together, but this is going to give you 4 fourths. So remember, that is equal to 1. So you can put that 1 together with whatever you have, and you'll have 1 whole number for the answer here. Okay, so next let's look at this back page, and Frankie wrote an equation. 1 2/3 is equal to 3/3 plus 2/3. Well, is it true? Well, 3/3 is equal to 1, right? So 1 plus 2/3 is equal to 1 2/3. So I would agree with Frankie. And what are 3 more equations that are true and different? You can only use fractions with 3 in your equations. Well, you could do 1 plus maybe 2 fractions with the third. Also remember that 1 2/3 is equal to 5/3. So really anything where you're getting 5/3, so 2/3 plus something that would give you 5/3, any of those would work.
Oh, it's gone.
And finally, we have some grids, and Frankie's was 10 by 10 and Lori's 8 by 8. And the teacher said shade in 1/4 of your grid. So to do 1/4 on these grids, probably the easiest way would be cut it in half, and then cut your half in half again, and then you have fourths. Or with Lori's grid, because it's 8 by 8, you could also do it, cut it vertically or horizontally. But you could also do it the same way. I'll let you figure out how to do Lori's grid. And then if you're shading in 1/4, how much would Frankie's grid be? And then do the same for Lori's. And you should have different numbers, but the question is, why are they different numbers? They're both 1/4. Why are the numbers different for those? So think about what you're starting with, and that should be the answer to that. And thank you, and goodbye.